Alright, so most of our techniques focus on right triangles, the Pythagorean theorem, special right triangles, even when we use SOHCAHTOA, that's all for right triangles. But we can use sine and cosine to solve other triangles also, outside of right triangles. And we looked at the law of sines before, now we're going to look at the law of cosines. Now when we look at the law of cosines here, it starts off, it does look the same as the Pythagorean theorem. Okay, so that's a good place to start. Start by writing the Pythagorean theorem down. Then you have to memorize what to put at the end. So it's minus 2 times these two sides that you have here. So AB, and then it's the cosine of the angle that matches this side. Now, what I would like you to do next is I would like you to try to write that same formula down except putting a over here. So putting a squared first. Except on your paper, hopefully your hand is going to cover up this. So you're going to try and memorize this right now, sort of. So cover that up, and underneath it write down a squared equals, and so if we have a squared over here, then we would have b squared plus c squared minus 2, and then these two, so bc, and then the cosine of a. Alright? And now underneath that, and obviously you could just sit there and look at that and write it down. That's not really going to help you memorize it. What you really need to do is cover these both up, and now we're going to try and do it for b squared. So down here put b squared equals a squared plus c squared minus 2ac times the cosine of b, which goes with that. And in doing that, in writing these two things down by covering those up, then hopefully we're starting to memorize that. Now, don't get too overwhelmed with this lesson. It's something you're going to see again next year and probably the year after that. So just try to do the best you can with it. So, solve the triangle if possible. So if it's not possible, there'll be different things that'll happen where we'll notice some problems. So here we have side-side angle. So we have it set up like this. So when you're using the law of cosines, now we know this is not the law of sines because in the law of sines we have to have a side and an angle together to set up the law of sines proportion. So since I'm going to try to find A because I have angle A and I have the other two sides. So again, try to remember the formula. So the formula is going to be a squared equals b squared plus c squared minus 2a, well, that's b and c. A squared equals b squared plus c squared minus 2bc, which is just those two numbers right there. And then the cosine of angle A, which is 60 degrees. Alright? So if we square that, it's going to be 400 plus 900 minus 40 times 30 is 1200. And the cosine of 60, we can figure that out on our calculators, or maybe we have it memorized, probably not, but we talked about that the other day. It would be 1/2. In your next class, you probably will have to memorize that in Algebra 2 Honors. I don't know if they make you memorize it in Algebra 2 regular or not. Okay, so that's going to be 1300 minus 600, which is 700. So a squared equals 700. So we take the square root of both sides. That's square root of 100 times the square root of 7. So that's going to be 10 root 7. And if this is a different angle, actually most of you don't have this memorized, so you would just type that in your calculator and get that number. If we were in class, we would have you leave it as cosine of 60 because we don't use calculators in class normally. Alright, so now what we want to do is, once we have that, now we have to find these two angles. So when you have side-side angle, you want to find the smallest angle first. And of these two, we know that the smaller side has the smaller angle. So we're going to try to find that. So what we can do now is we can use the law of sines, because the law of sines is less stuff in it. So we're trying to find the measure of angle B. So using the law of sines, that's going to be the sine of angle B over B equals the sine of angle A over A. Alright? So we're going to multiply both sides by 20 here. And that'll tell us that the sine of B equals this. And we can reduce this a little bit. 10 goes into 20 twice. Alright? So we're trying to find an angle. So when we try to find an angle, we do the inverse sine. So in class, what we would do is we would write it like this. Inverse sine. And then we're going to have 2 sine of 60 degrees over root 7. And that's going to be degrees, because this is going to be an angle. The inverse sine is an angle. Now, because you're at home on the Alex, I'm not sure what the Alex is going to have you do, so you might need to type this in your calculator. And on the phone, it's a little bit tricky. So you're going to do the sine of 60, and then it'll give you a decimal, and then you'll take that times 2 and hit enter. Then you'll divide that by root 7. And then once you have all that, then you'll hit second sine, which is switch it to this, and type that in. And when you do all that, that turns out to be 40.893 degrees, approximately. Okay? Now, at this point, what we would do is we have two angles. So we would just add those together and subtract from 180. So we would take 180, and if we added those together, that would be 100.893. So if we subtracted that, that's going to be 79.107 degrees. Okay, and now the triangle is solved. We have all the sides and all the angles. Okay, so we're just going to try that a couple more times, plugging into that formula. It is a lot, but we're just doing this one page, and then we're going to do a couple review problems after that. So hopefully when you look at this, you notice right away that there's not a lot of space right here. So if you go back up here, it says solve for the triangle if possible. So probably an educated guess would be that this one's probably not possible because we did not leave a lot of space here. So when you have three sides, what you need to do is, remember, add the two smaller sides together and compare them to the larger side. Now these are not long enough. They don't reach across 9. The two smaller sides are less than the bigger side. So there's no triangle there. Okay? So it's not possible. You can't make a triangle out of that, connecting them end to end. Okay, so that one is out. Now, for this one, if we take two smaller sides, 10. 4 plus 6 is 10, and 10 is greater than 9. So the two smaller sides added together are more than the biggest side, so that does make a triangle. Okay, so we can just put the sides on here. A is 6, B is 9, C is 4. So that's going to be the measure of angle A, and the measure of angle B, and the measure of angle C. Now, for side, you find the largest angle first. So our largest angle here is going to be across from the largest side, so it's going to be B. So we're trying to find the measure of angle B. So using the law of cosines, we know we can't use a law of sines because we don't have any of the angles. To use a law of sines, we need an angle and a side that go together. So it's got to be law of cosines. And since we're trying to find angle B, that means we want to start with the formula that starts with side B. So that's going to be B squared equals A squared plus C squared minus 2AC and then cosine of B. Okay, so we're just filling in the formula up there. So this is going to be 81 and 36 plus 16 minus 24. No, that's 24. 24 times 2 is 48. Okay. 48 cosine B. So if we add these two together, that's 52. So we're going to subtract 52 from both sides. Now be very careful here. Some students make a mistake and they try to subtract 48 from 52. You can't do that. This is order of operations, and you got to multiply before you subtract. So these are together, so we can't do this. Don't subtract those numbers. So we're going to subtract 52 from both sides. So that's going to be 9, 7, 29. So 29 equals negative 48 cosine B. So we're going to divide both sides by negative 48. Alright, and now we want to find the angle. So the angle is the inverse cosine of negative 29 over 48 degrees. Okay, and if you type that in the calculator, that turns out to be 127.169 degrees. Okay, now at that point we can switch to the law of sines now. So now what do we want to do next? We should be able to do either one. So if we find A next, that's going to be the sine of A over 6 equals the sine of 127.169 degrees over 9. So if we multiply both sides by 6, that reduces to 2/3. So we're trying to find angle A, so we would use the inverse sine of A. So the inverse sine of 2 times the sine of 127.169 degrees over 3. And if we type that in the calculator, it's a little bit tricky, but we should end up with 32. 32.089 degrees. Right here. Alright, and now again we have these two angles, so we can add those together and subtract that from 180. So that would be 159 point whatever. So 180 minus 159 point whatever is going to be 20.742 degrees. 180 minus A plus B. Alright. So last one of those before we review a little bit. so we have x, y, and z. So let's go x and y. Y is 14 and z is 8. And the measure of angle x is 50 degrees. And the measure of angle y and measure of angle z. Okay, so first thing we want to do is find x. So that's going to be I'm trying to squeeze that down here. X squared equals 14 squared, which is, maybe we can just do that. 14 squared is 196 plus 8 squared is 64 minus 2 times, can we do this? 80 and 32 is 112 times 2, 224. Cosine of x. Alright, so we would square root that and square root that. So we would add these together though, so that would have been 260 minus 224. So if we were in class, we would just have you write that down. 260. Remember, don't subtract those because you have to take the 224 times the cosine of 50 doing order of operations. You have to multiply before you subtract. Okay, so that on a calculator would be 10.771 centimeters. Okay, I know this can be a little bit intimidating. Just do the best that you can. Try to follow along. You're just plugging numbers into the formula and trying to simplify it a little bit and use your calculator there. Okay, so we go back to example 1. This is a side-side angle example. So smallest angle first. So out of these two, the smallest angle is going to be z, because 8 is smaller than 14. Okay, so now we're going to set that up. So the sine of z over 8 equals the sine of 50 over 10.771. Okay, so we're going to multiply both sides by 8. And then remember, we're going to take the inverse. We're trying to find an angle, so we're going to take the inverse sine. So that was angle z down here. So we have the inverse sine of 8 times the sine of 50 degrees over 10.771 degrees, which, if we type that in the calculator, should be 34.678 degrees. And if we add those two together, we're going to be taking 180 minus 84.678. That's what we get when we add those two together. And when we subtract those, we're going to get 95.322 degrees. Okay? And that's pretty much law of cosines and the different situations that we would be in to solve those. And you can see this involves a lot of stuff, and that's why some people have a hard time with math, because it involves a lot of different things, and that's why there are a lot of good paying jobs for people who can do math. So stick with it, hang in there. Let's do a little bit of review now. So real quick, we're just going to review some stuff from chapter 9. Now, these examples are all in your notebook already, although that's the page number of the section actually, not the page number of the notebook. But it's in 9.1, example number 5. This is the same question. So if you need to look those up. Now, when you see this similar right triangles, this picture, always try to get the hypotenuse on the ground. Is kind of how I think of it. So that's the first step. The other step is you always want to know the whole hypotenuse. So you want to look at the picture and say, is there a way I can get the whole hypotenuse? Okay, so number 1, get the hypotenuse on the ground. Hypotenuse, ground. The hypotenuse of the big right triangle. Always get the whole. So here we have a right triangle, and we have two sides. We want to find the hypotenuse. That's a squared, b squared, c squared. So c squared equals 16 plus 36. So square root both sides. So that's 52, which is 4 times 13. So that's 2 root 13. Okay, this one's a little bit nicer, just 4 plus 16, so that's 20. Okay. So here, when we see these pictures, automatically think of a proportion. So when you see that, you should immediately think that there's a proportion involved. Okay, or you can use the chart that Ms. Muko showed you as well. But either way, it involves a proportion. So if you set it up like this, remember that these three things that go up are always geometric means. Okay, so this are geometric means. Okay, so in this one, 4 is the geometric mean, so I can put that here and here. 4 is going to be the geometric mean. And for the two legs out here, they are the geometric mean between the piece of the hypotenuse that's closest to it and the whole hypotenuse. So that would be x, and the whole hypotenuse would be 2 root 13. Okay, so this reduces to 2, and if we multiply both sides by 4, we're going to get 8 over root 13, and we should rationalize that. So that's going to be 8 root 13 over 13. Alright? Now, let's go over this one. So we're going to have this 3 times, so a proportion again, right? And A, we just said, was the geometric mean. All 3 of these are going to be geometric means. A is the geometric mean between the piece closest to it and the whole hypotenuse. Okay, I'm going a little bit faster. You could pause this and do it yourself. It's good practice. So if we cross multiply, we're going to have a squared, and then we're going to have 4 times 80. So if you think about that, 80 is 4 times 20. 4 times 20, but 20 is 4 times 5. So if you look at that, we actually have 64 times 5. So if we just root that right now, we get 8 root 5. Okay. Now let's move over here and do C next. I know I like alphabetical order, but C is the same setup as A. So what I'm going to do there, I'm going to do C over here. So again, a proportion, and again, this is the geometric mean. All these circle things are geometric means. So C is a geometric mean between the piece closest to it and the whole thing. So if you cross multiply that, you get C squared, and you get 16 times 4 times 5. I'm factoring that to get perfect squares, and we already saw 16 times 4 up here. That's 64. So we could do it that way. The square root of 64. So that's going to be, hold on a second here. Why did I do 4 over, why did I do 80 here? That's a mistake. So that was supposed to be over 20. Yikes. So that should have been 4 and 20. Oh, I multiplied those. I got 80, I guess, in my head. I wanted to do more math. Alright, so that should have been 20, which would have been 4 times 5. So that would have been 16 times 5. Yikes. Okay, so 16 times 5, which would be 4 root 5. Sorry about that. Okay, hopefully a couple of you noticed that and you were like, hey, Mr. Christensen, that's 20, not 80. Okay. Anyway, back to this. So now this, we could do 64. The square root of 64 would be 8 root 5. Or you could do them separately. The square of that's going to be 4. The square of that's going to be 2. And then that's going to be root 5. Just make sure you multiply those together. So that'd be 8. Whew. Okay. Now, B, the altitude, is a little bit different. It's still the geometric mean. All three of those things that go up are the geometric mean, so that's B. And it's the geometric mean between the pieces of the hypotenuse. So that's going to be 4 and 16. So that works out rather nicely, actually, as 8. Now, maybe a couple of you are saying, hey, that should be plus or minus 8. The mathematical answer for B would be plus or minus 8, but these are length. That's a length. And so it doesn't make sense to have a negative 8 length there. So that would just be 8. Okay, moving on to the next section. That was the Pythagorean theorem. And we want to look at this word problem that we've asked several times. So, in math, and particularly geometry, drawing, sketching, pictures can be pretty helpful. So, we're going to do this. Short leg, they're both compared to the short leg, so that's what we're going to use for our variable. And then the hypotenuse is 2 less than triple. So 2 less than triple. And the longer leg is 2 more than the shorter leg. So that's going to be x plus 2. So that's going to be... So really what you should do on the rest of these are all review, is you should just try to do this all and then fast forward through it and check the answers and make sure that you got them all right. Or flip in your notebook and check them. But this is good practice for you. Okay, so I'm going to try to speed up a little bit here because you should be pausing this anyway to get it done yourself, to practice. Okay, so the Pythagorean theorem, a squared plus b squared equals c squared. So that's going to be, now remember we can use the box method to multiply these out if we want to. 3x minus 2. However, as honors students, we also could probably just have these memorized, so you square the first thing, multiply those together and double it, and square that. Same thing here, square this, multiply those together and double it, square that. Okay, so if you subtract 4 from both sides, those cancel. Now we're going to move these over here, so there's 2x squared here, so I'm going to subtract 2x squared from both sides. That's going to be 7x squared, and then we're going to subtract 4x from both sides, so that'll give us, and technically the 0 would be on the left, but we can flip the whole thing over. Looks a little bit better that way. So that's 7x minus 16, and so x is either 0 or 16 over 7. Okay, and if you need help with that, you can actually solve that out like this and add 16 to both sides. But when you get better at it, you'll just see the pattern a little bit faster. Now, we have a problem here. If we plug 0 into this triangle, that would be, this side would be 0, this side would be negative 2. That doesn't make sense, so we're going to eliminate that answer. Okay. And some factoring real quick down here. So no GCF, always check for a GCF. So we're going to do 1/3 and 3x, and this is plus, so they're the same sign, and this is plus, so they're both plus. This times this is 30, so we need factors of 30 that add up to 17. 1 and 30 definitely not going to work. 2 and 15 looks good. 2 plus 15 is 17. Now we're going to factor out the GCF out of here, and that should cancel this out, which it does. So we just have 3x plus 2 and x plus 5. Okay? So I'm just going to go real fast because this is going to be on the longer side as it is already. So no GCF, 1/8, 8x, 8x. Positive, so they need to have the same sign, but this is negative, so they both need to be negative. Okay, 8 times 5 is 40. Factors of 40 that add up to 22, 2 and 20. So that's going to be 2 and 20, or 20 and 2, doesn't matter. And so I can factor a 2 out of this, and I can factor a 4 out of that. And you can always check factoring by multiplying it back together and seeing if it gets that. Okay, so moving right along, same thing, 8h, and that's negative, so now the signs are going to be the opposite. Now we're going to be subtracting the factors. So 8 times 15 is 120. I need two factors of 120 that up to 14. That's a little bit awkward. I'm going to skip down, I don't know, 6 and 20, subtracting, and I got it right. That's kind of lucky, a little bit. I mean, not totally, but because if I subtract those, I get 14. So it needs to be positive, so the 20 needs to be positive, and the 6. And if you don't find it right away, then you can guess on either side. It depends how close you are to that number. So here, if we factor out a 4, that'll be 2h plus 5, and here we can factor out a 2, so that'll be 4h minus 3. Okay, and moving over to this one, no GCF, 1/3, 3z, 3z, and that's negative, so opposite signs. That's going to be 90. So, I don't know, 3 and 30. If we subtract those, now we need to keep going. We need a bigger number. 4 doesn't go into that. 5 goes into that. How many times? 18. That's it. Okay, so negative, so 18 and 5. So 3z plus 5. Now again, if you're just booking and copying this down, then that's not really practice. You're just writing what I'm writing, you're not really thinking about it. So pause. So one more page here. This is similar to the ones we just did. So the hypotenuse is already on the ground. These are geometric means. We should be thinking of proportions immediately. So I can see that these are both x's, and that's 10, so that's kind of telling me where I should focus on here. So 10 is the geometric mean between the pieces of the hypotenuse. This reduces, so we get x squared equals 50, which is 25 times 2. So if we square root that, we get 5 root 2 for x, which I don't see an x on there anywhere. So x is 5 root 2, so this is going to be 5 root 2. This is 2 times, I guess I could have finished that, 5 root 2. So this is going to be 5 root 2. This is going to be 2 times that. That's going to be 10 root 2. And the whole hypotenuse is going to be those two added together, so that's going to be 15 root 2. Okay, and now, so this is a little awkward, but probably this should say x. Okay, so I use orange highlighter when I want to fix something. So you don't have to highlight it in orange. That's just for me, letting me know we need to fix that. So we said x is 5 root 2, and I actually would like to put that on top. So I guess I should have done that in orange also. Okay. Anyway, back to this. Let's wrap this up. Now I'm going to find A. So A is the geometric mean. Remember, all these things that go up are geometric means. So A is the geometric mean, piece closest to it, and the whole hypotenuse, which is 15 root 2. So if we do that, we're going to have A squared, and let's see, that's going to be 5 times 5 times 3 times 2. I don't know if that's too tricky, if I lost anybody there. 5 times 5, that's 25, times 3, because there'll be a leftover 3 from the 5 times. This is 5 times 3 is 15. And then the root 2 times root 2, that's just going to be 2. So if we root all of that, that's going to be 5 root 6. So A hopefully is 5 root 6. And then lastly here, I don't know if I can squeeze that in here. I'm going to do it up here. So again, geometric mean. When you see this picture, it's all about the geometric means, 3 of them. So now I'm looking at B. B is the geometric mean between the piece closest to it and the whole hypotenuse. So again, cross multiply that. Now, this is a little bit trickier. Let's see, we've got a 5 times 2 here, and we had a 5 times 3 here. So 5 times 5 is 25. Now we have a 3 and a 2, but we also have another 2 right here. Root 2 times root 2 is 2. So I'm kind of getting maybe a little bit, so we got that times that, and then, I don't know, maybe I'll put a root 4. Maybe that'll help you focus it better, root 2 times root 2. Anytime you multiply a square root times itself, you just get the number, so really I should have just put a 2 there. But so that's 2 times 2 is 4, that's 100 times 3. So that's 10 root 3. Okay. Decide whether they can be a triangle. So 8 plus 18 is greater than 24. That's 26. So that is a triangle. So let's find out what kind that is. So that's going to be 64 plus 18 squared. I don't know that off the top of my head. So 64, 144, 324. And 24 squared, is that 576 maybe? I think it is, if I remember from other problems we've done. So if I add these two together, they're definitely less than that. So the bigger side is bigger, so that's going to be obtuse. The bigger side squared is bigger, so that's going to be obtuse. Okay. And here, 3.2 plus 4.8 is definitely bigger than 5.1, so it is a triangle. Check. Now, if we multiply those out, I'm not too excited about this. I'm going to use a calculator. We shouldn't use a calculator all the time. You notice how I did some math over here, but we can use a calculator sometimes. So 3.2 squared is 10.24. So that's going to be 10.24 plus 4.8 squared is 23.04. And 5.1 squared is 26.01. 26.01. So now that's definitely bigger. We don't need the actual number, but I can tell pretty quickly that's 33. That's bigger. So now the bigger side squared is smaller, so that's an acute triangle. Remember, if they're equal, it's a right triangle. Okay. Whew. Now, again, this is all review down here, so if you're good, you could go through that pretty quickly. But special right triangles, very important. Long leg to short leg, we divide by root 3, so that's pretty simple here. That's just going to be 5. And then here, short leg to hypotenuse, we double it, so that's going to be 10. So that's nice and fast. Hypotenuse to short leg, divide by 2. Now be careful that you pay attention to where that is. That's a little bit annoying. These should be switched, but whatever. Half, so that's going to be 36, and then short leg, long leg, we multiply by root 3. So that's 36 root 3. Okay? Let's move down here to 7 because we'll keep that same pattern. So here, long leg to short leg, divide by root 3. So divide by root 3. So here it was nice because 5 root 3 divided by root 3, that just canceled out. But now it doesn't, so we have to rationalize. So now we're going to have 15 root 3 over 3. I know this is fast, but it's review, and it's already been a long lesson. So, and then to go from the short leg to the hypotenuse, we double that. So we had 5 radical 3's. If we double that, we'll have 10 radical 3's. Okay? And over here, we're going to take half of that. So that's 4 radical 6. Again, it's down here. So 4 radical 6. And then multiply by root 3. So that's a little bit tricky. So times root 3. That's going to be 4 root 18, which is 9 and 2. So that's 4 times 3, so that's 12 root 2. All right. let's finish this up here. So when you see this 45, you should automatically know this has to be isosceles, a right isosceles triangle with a 90 and a 45. That's also 45. So f has to be 5, and to go from here to here, we multiply by root 2. So that's root 2. This one should be super nice. We divide by root 2. Well, that would have been here actually. So, but they're both 7, so that's fine. So this is still pretty easy because that's isosceles. Those are equal. Now it gets a little bit trickier. We need to multiply by root 2. So if we multiply by root 2, we get root 28. So that's going to be 2 root 7, making sure it's in the right spot, G. Okay. And going backwards, divide by root 2. So we have 8 root 6 over root 2. That's going to be 8 root 3 for both of those. We can divide that. Wow. Okay, that's about it. So there's a lot of review that took a long time, but have a good day. It's about that time.